going to log in, you know the username, you know the password. We're going to start up Wireshark. I'm just going to go in here and just look for Wireshark. Just type W, it is right there. Hey, keep in mind, if we're moving at a fast pace, that is intentional. We are intentionally moving at a swift pace so that we can record as much information within a limited amount of time so you don't just get bored staring at the screen. All right, we're gonna capture traffic on this interface right here, ETH0, right? The interfaces are what we use to establish a connection or just connect to other networks. Now, what are we gonna do? All right, first things first, we're gonna go to structurereality.com. reality.com. Boom. Once that is done, we're going to go back to Wireshark and we're going to stop that capture, right? Because it's going to capture everything. We don't want it to be as noisy. All right, we stopped the capture. What do they want us to do next? They want us to use Wireshark to examine the capture frames. All right, let's just take a look at what we're looking at real quick. I'm going to go all the way to the top. If you're not familiar with Wireshark, this is your first time looking at it. Right now, on the left-hand side, we have the packet number. After the packet number, we have the time the packet was captured. We have the source the packet came from, the destination that the packet is going to. We have the protocol being used, the length of the packet, and some information about what's going on. Now, first thing, what is the IP address of structurereality.com? All right, so we have to, let's just filter out for HTTP traffic. Just type HTTP in this display filter. This display filter is only it's gonna filter out it's going to filter for what we're looking for. And right now we just want to look for HTTP traffic, right? Because we had established that session with structurereality.com over here. This is over HTTP, it's not being encrypted. All right, so the IP address is right there. 172.16.0.201. Boom. All right, next, they want us to clear the display filter already. All right, cool. Oh, use Wireshark to determine if any DNS traffic was captured. So we're gonna go back, switch this from HTTP to DNS. That's simple, right? And a bunch of DNS traffic was captured. It had to be captured, right? And when we're going to different websites, different web servers, different applications, that we have to ask the DNS server for their IP address. All right, cool. Let's go into the next section. We're not done with Wireshark. We are not done with Wireshark. All right, what we're gonna do is clear this, and we're gonna start up a new capture. Continue without saving. To start up a new capture, you just go back over here and select this start button. We're gonna continue without saving. We're gonna go to a different website. We're gonna go to DVWA now. All right, now we're gonna go back to Wireshark and stop the capture. All right, now we're gonna play around with this display filter a little bit more. It says use Wireshark display filter to display only captured frames that include this IP address. So we're gonna do that. I believe it's ip.addr. They give examples too. ip.address equals 10.1.16.66. This is only gonna show us traffic going that involves 10.1.16.66. It doesn't matter if it's the source or the destination. That is the only traffic that we want to be displayed out of everything. All right. Next, create a new display filter that shows captured frames that have a TTL value of 128. I believe that's ip.ttl. And it has to be below 128, so less than 128. All right, so this is gonna show us the TTL value that is below 128, right? If you're not familiar with TTL, this is simply the amount of time or the amount of hops that it takes a packet to exist within a network, right? Before it's thrown away by the router. Right, this is pretty much the life of a packet, right? The TTL life of a packet. All right, now the captured frames or TTL are below 128. Alter the display filter to include ARP frames. Pretty easy. ARP is a protocol, so we just put the protocol here. for the most part with protocols, we can just give the protocol name and it will filter the display to only that protocol, right? ARP is a layer 2 protocol that we use to update our ARP table. Right, if you're not familiar with that, I highly recommend to get into our Security Fundamentals Academy. We go into ARP into extreme details, especially when it comes to ARP poisoning attacks. All right. To include, we have to include ARP. So let's go back to IP dot. We're going to do this. And to include ARP, we're going to do OR ARP. So we're going to have the TTL and ARP packet shown. Right? If you do and, you probably won't get anything because you need both. And it's looking for this and ARP. So I did OR instead of and. All right, create a new display filter to show frames that do not contain the IPv address. Okay, we're gonna do ip.addr does not equal, so that's exclamation point, does not equal 10.1.16.66. We probably won't get anything yet because all the traffic going out of our interface is using this IP address. Cool. Use the display filter expression syntax windows to create a display filter. Display only TCP packets with the fin flag set. All right, fin flags are a pretty big deal. TCP.flags.fin equals 1. This is going to show us where the fin flags are set. If you're not familiar with the flags, once again, Security Fundamentals Academy, right? There are a bunch of different flags that are set within a packet. You have push flags, fin flags, act flags, synact flags, send flags, reset flags. They all have their different purposes. Okay, only with that. All right, the display frames. Yep. What is the IPv4 source address of the system that used the first fin flag? That is going to be us. That is 10.1.16.66. Boom. All right, modify the current display filter to remove frames that have the ACK flag set. We don't want to see frames with the ACK flag set, so we want ACK equals 0. That is another flag. We don't want to see frames with the ACK flag set. All right, if you wanted to see them with the ACK flag set, you would do equals 1. All right. Edit the display filter to display frames with fin, but not sin set. So you already get the gist, right? We want flags, so we want the fin flag set equals 1 and tcp.flags.sin equals 0. All right, so this is showing us TCP flags. It's showing us packets. Right, it's only displaying packets that have the fin flag set and sin flag not set. Right, fin flag set and sin flag not set. Okay, we're gonna clear that and we're gonna go to the next section. All right, right now we're just utilizing Wireshark to show us different things. If you wanted to see TCP packets where data was being sent across your network, you would set you want this push flag equals 1, right? This is where we can just limit to data being sent across the network. We're looking at all data that's being sent across the network with this push flag set. Right now, if you wanted to see connections being established, we could use a SYN flag, right? Because the SYN flag is showing us when people are trying to establish some type of connection, right? It may not be fully established, but at least we're trying, right? When we went to this website over here, we said, hey, are you online? That's where you see this SYN flag right here, right? We see the flags right here, you all. Right, we see the flags right here. Like if I break something down, let's just look at HTTP. I'm gonna go to the top. Oh yeah, no. I'm gonna clear the filter. Right, so look, I just saw it. So look, we just see the SYN flag, right? Our system right here is saying, hey, are you online? That's the SYN flag right there. Next, that system responds back to us, right? It was the destination over here. Now it's right here as a source. It's responding back to us saying, hey, yeah, we are online. That's SYN ACK. And then we finally respond back saying, okay, cool, you're online. That's the act flag. We're acknowledging that you're online. Get ready, because we're about to ask you for something. And that's what we did in the next line. We asked it for this web page right here, to get a web page. Remember the HTTP verb. We're trying to get a web page. All right, next. We're going to use this same stream right here. This same stream, the same stream, the same stream. We're going to use the display filter to locate the first frame of the communication with DVWA. Let's just type dvwa.structurereality.com. Actually, let me get some assistance. I think I'm missing something. Okay, TCP contains structurereality.com. All right, now this is going to filter just for the TCP package that contains structurereality.com. We can go ahead and try to piece this together, right? Instead of looking at the packets individually, we can go ahead and analyze this entire stream together. So how do we want to do that, right? So what we're going to do is come up to analyze right here, or you could right click, but we're going to come up to analyze up here, and we're going to select follow. We want to follow that TCP stream, right? And now we're looking at everything between the server and the client. All the packets that are, well, the traffic that's in green, in red, I said green, I don't know why. This traffic that's in red, that's coming from the client, that's coming from us. We're trying to get this web page over here. This is the host that we're trying to get it from. This is our user agent. We're using Firefox, okay? And this is the server that's responding back to us. You see how I'm clicking back and forth? The packets are changing, right? The packets are changing in the background, right? This is the server responding to us. They gave us, it's a 200 okay. This response code is 200. We have different types of HTTP response code. This one is successful. So whatever we asked for up here, which was this web page, it was successfully given to us. All right, let's go look at a different stream. We're gonna look at HTTP stream. So let's filter this out for just HTTP traffic. All right, cool. You can make sure open and follow HTTP stream. Frame containing the TCP request. Oh, let me make sure I didn't skip anything. Okay, with that, all right, cool. All right, so now we're gonna follow a HTTP stream going over here. All right, containing this TCP request. All right, so we can do TCP contains switch this guy out with plainenglish.co.uk. All right, that's not giving us anything. All right, let's just go to HTTP. Well, we can go to that website actually. Let's go. Well, we're not capturing anything. All right, we're not capturing anything. So what I'm going to do, because the capture isn't started, we're just going to filter out for HTTP traffic, right? Because we can do the same thing that they want us to do over here with HTTP traffic. I'm going to do it this way first, and I'm going to see how they did it over here. And we're just going to go to analyze. Same thing. We're looking at HTTP traffic. We're going to go up to analyze. We're going to go to follow, and we're going to follow HTTP stream. Right? We can see the same thing. We can see the client. We can see the server. Right? But this time it's not encrypted, so we can see what's going on. Right? It's HTTP this time. It's not using any type of encryption right here. Right? HTTP is using port 80. HTTP is not encrypted, so we can see everything that's going on this website. All right, the next question says, attempt to locate the HTTP stream segment from the web server. So we want to find welcome to damn vulnerable. All right, that's easy. All we got to do is come down here in this find bar right here and just type some of that in. Welcome to damn. And if you hit enter, well, welcome. Hold on. There we go. All right, we have welcome right here. Welcome damn vulnerable web application. Boom, that's it right there. All right. right? But this is the one they wanted us to look for specifically. So I just filtered out for H1. Welcome to damn vulnerable web application. I specifically filtered out for H1 to get exactly what they wanted us to look for. All right, but I want to see what they did over here. Yeah, we actually have to capture that first though. All right, we're gonna keep moving along. What color and from which side of the conversation is the HTML code of welcome to DAM? This is coming from, it's blue, right? We don't have to guess. It's down here, right? You can see the server is in blue. The client is in red, right? We're not guessing, we're not making anything up. So it's blue and it's coming from the server. All right, cool. We're going over to our questions. Wireshark is a pretty cool tool, y'all. You got to get used to it. I mean, you may not be even using it on a daily basis. Just get familiar with what's going on here, right? How this is structured. You have your time, you have your source, the destination, protocol, length, info. You get more information down here, right? To start understanding and getting in more details about each individual packet. That will be down here. And also right here, there are 3 frames. This frame, this frame, this frame, or 3 panels, whatever word you want to use. All right, question. What is the proper term for the network communication container at the data link layer? That's going to be a frame. Pane of the Wireshark interface can be used to view the contents of a packet's payload in both hex and ASCII. That's going to be packet data. What display filter comparison operator is used to express the concept of 2 values not being the same? That does not equal. Which of the following statement is true? Capture filters are used to highlight specific frames already present in the... No, that's not true. Display filters limit the packets accepted. Capture filter, display filter are used to find packets matching. Yes, here we go. Right, you have packet filters and you have display filters and you have capture filters. They're 2 different things. What is the primary factor that determines what header or payload information can be viewed through a network sniffer? That's going to be encryption, whether it's encrypted or not. All right, that is it, y'all. If you enjoyed this series as much as I did, please smash that like button. Don't forget to subscribe. Right, we go into way more details of a lot of these applications, a lot of these tools that are being used throughout this labs in our security fundamentals course, right? Because there are fundamentals to these things. These lab series are just to get you through them and to help you understand what you're doing and why you're doing it. Without these walkthrough videos, you're really just going through the what, right? CompTIA is telling you what to do throughout all of these things, but you don't really get a solid understanding of why. Right, so that's the main point of the walkthrough videos here, is to give you that solid understanding of why. But if you want to get the fundamentals, the basic building blocks of all of these things, all of these tools, concepts, and technologies, the Security Fundamentals Academy is for you. Go to olinesecurity.com and register for our Security Fundamentals Academy. Peace. See you next time.